All right, let's talk about our next-door neighbor in the cosmos, Mars. It's so much more than just that little red dot you see in the sky. I mean, we're talking about a world of absolutely massive volcanoes and maybe some incredible ancient secrets. And you know what? Scientists are getting so close to cracking its biggest mystery.
And that brings us to the big one, right? The question that's behind all of our fascination with this place. Could Mars have ever had life? That's the core mystery we're going to dig into today. And we've got some amazing clues to work with, sent back to us from our rovers and orbiters.
Okay, so with any investigation, you got to start with a profile of your subject. So, how does Mars really stack up against Earth? Are they like cosmic twins separated at birth, or total opposites? Well, the answer is kind of both, actually.
So you look at them side by side, and right away you see some pretty big differences. For starters, Mars is tiny, only about half the size of Earth. And since it's farther out from the Sun, its year is almost twice as long as ours. Seriously, can you imagine waiting 687 days for your next birthday?
But then you look at the length of a day, and this is where it gets weirdly familiar. A Martian day, which they call a sol, is 24.6 hours long. That's almost the exact same as ours, so even with this totally alien world all around you, that day-to-night cycle would feel, well, it'd feel a lot like home. So we've got this planet that's this weird mix of alien and familiar. To really get a handle on it, though, we've got to take a look at the scenery. And let me tell you, what a scene it is. We're talking a tour of some truly unbelievable extremes. So first things first, why do we even call it the Red Planet? It's not just a catchy nickname, you know? The ground there is full of iron minerals, and over billions of years, all that iron has basically just rusted. Yeah, the whole planet is literally covered in a fine layer of rust dust. And the scale of the features on this planet is just mind-blowing. I mean, Mars has a volcano that makes Mount Everest look tiny. It's got a canyon system that would just swallow the Grand Canyon without a second thought. Oh, and it's got two little moons that are probably just captured asteroids. Let's zoom in on some of this stuff.
Okay, let's talk about that volcano. It's called Olympus Mons. This thing is so massive, so wide, it would cover almost the entire state of Arizona. It is an absolute monster.
And to really get your head around the height, picture Mount Everest. Now stack 3 of them on top of each other. That's how tall we're talking. It's so big that if you were standing at the bottom, you couldn't even see the top. It would be over the horizon. But Mars isn't done showing off. Nope, it also has Valles Marineris. And this isn't just a canyon. It's a whole system of canyons, all connected. It honestly makes our Grand Canyon look like a little crack in the sidewalk.
Just how massive are we talking? Well, it's over 2,500 miles long. Think about that. If you laid it across the United States, it would literally stretch from New York City all the way to LA, the entire country.
Okay, so with all this incredible geology, why is Mars so cold and dead? The main culprit here is its atmosphere, or what's left of it. See, billions of years ago, Mars lost its magnetic field, and without that protection, the solar wind just blew most of its air away. What's left is super thin, less than 1% of Earth's air, so it just can't trap any heat. And that thin atmosphere also cooks up some pretty wild weather. Mars is famous for its dust storms, and I'm not talking about little dust devils. No, we're talking about storms so huge they can cover the entire planet for months, blocking out the sun completely. You can imagine what a nightmare that is for our solar-powered rovers over there. But you know, for all the talk about rocks and dust and volcanoes, the single most important clue we're looking for is water. Yep, the story of water on Mars, that's the key to unlocking this whole mystery. And the evidence we've found is it's overwhelming. Our rovers have seen it all: dried up riverbeds, ancient deltas, minerals that could only have formed in water. It all points to one thing. Billions of years ago, Mars wasn't the desert we see today. It was a wet world with rivers, lakes, and maybe even oceans.
But then you look in Mars today. It's a frozen, dusty desert, a place where liquid water just can't last on the surface. That is a huge change, and it's a puzzle that scientists are working really hard to solve.
So that leads to the million-dollar question, right? If Mars used to be all wet and watery, where did all the water go?
Well, here's the cool part. It's still there. It didn't just disappear. It's just locked away. A whole lot of it is frozen solid in the polar ice caps, just like here on Earth. And get this, scientists think there could be a lot of super salty water, brine, flowing deep under the surface, where it's protected from that crazy environment up top.
So you might be thinking, why does any of this matter? Why are we spending all this effort to send robots millions of miles just to look at rocks and ice? Well, it's because understanding what happened to Mars, that helps us understand our own planet and maybe even our own future.
Really, we have three big goals when it comes to Mars. One, we want to figure out how it lost its atmosphere and water, which tells us a lot about how planets like ours change over time. Two, we are absolutely on the hunt for any sign of past life. And three, all of this is helping us figure out how we could one day send people there and have them survive. When you boil it all down, Mars is like this amazing scientific time capsule. It's just sitting there, holding the potential answers to some of our biggest questions. Like how do planets work? Where else might life be? And what does our own future out there in space look like?
And that's really what it all comes back to, isn't it? This dusty, cold, red planet right next door might just hold the clue to answering one of the oldest questions we've ever asked ourselves. Are we alone in the universe? The evidence is out there. We just have to find it.